Hello student, good morning to all. How are you all? Okay, fine. Okay, very good. So now we have today we will discuss the another question. Many questions we have discussed. Okay, but the new things today we discuss. Okay, what is the new things today we discuss about the magnet? Have you seen the magnets? If you have seen the magnets, then you know that's how many poles are there. How many poles are there? Two poles. Yes, one is north pole and another is south pole. Okay, I want to show here. You see, I have this is the magnets. Yes, this is the magnets. Okay, and you see that here is the north pole and this is the south pole. And one more is there, that is okay. I have two piece of magnets, that is the bar magnets. Are you able to see this ones? Okay, you will see that if here is also north and south. If you will notice that whenever okay at a certain distance the two poles are okay coming broad, what is happening here? You will see that it's attract each other. Okay, if you will see that this pole, then here is north and south like that, and that's why here is attraction. Now you can change this pole. If you will change this one, so see that now it will not attract and it is applying the force. Okay, it will try to repel. Okay, so you can see that the force is experienced due to these magnets. Okay, so we will discuss about these magnets, and you know that this is the permanent magnets. Okay, but one more is that is the temporary magnets, that is called the electromagnets. We will discuss that one, but before it we will know also the which topics we will study here. You know that we have the topics magnetic effect of current and magnetism. Yes, magnetic effect of current and magnetism. We will notice that with the help of conductors how we can make the coils, and due to coils whenever the current will flow, you know that due to rotations, due to movements, the current in that conductors it behave like as a magnet, but not that is the permanent magnets. If you will stop, if you will okay not allow the current passes through that, so it will not behave, it will not generate the magnetic field. Is it clear? So we have magnetic effect of current and magnetism. There are some topics just like we can see that first we have magnetic effect of current. Yes, another we have which force on charge. Yes, next we have force on current. Yes, force on charge, force on currents, and magnetic dipole. Yes, magnetic dipole and earth magnetism. And one more is there, that is the classification of magnetic materials. Classification of magnetic materials. Okay, so these are the topics, these are the highlighted topics we will discuss in the class. Okay, in the magnetic effect of current and magnetism. Means you know that in the first topic if you will discuss here, we have magnetic effect of currents. Yes, magnetic effect of current means what? If you will take the, suppose that magnetic, if you will give the name of chapters 1, that is the magnetic effect of current. Okay, magnetic effect of currents, and you know that's magnet. Okay, magnet, this is the material that having the charge percent. How many poles are there? 2 poles. How many poles are there? 2 poles. This is the north pole and that is the south poles. Okay, very good. So if you will see that's the direction of magnetic field lines, it moves like that. Yes, it forms a closed continuous loop. Which step? Closed continuous loop from north pole to south pole, like that it will forms. But whenever it will forms the closed continuous, and these two lines will never intersect. Is it clear? And you know that, and this is the which type of magnet? Permanent magnets. And temporary magnets, you will take the coil. Okay, coil means you take the longer wires, copper wires are wound that ones. If you will wound and connect with the battery, you will notice that due to flow of the currents in the coils, okay, after that you take another piece of, okay, irons, okay, you will notice that it will started to attract, or you can take the compass needle also. But question is that what is magnetic field? Okay, magnetic field. Magnetic field means what? You can say the space around current carrying conductors. Yes, it is the space around the current carrying conductor in which its magnetic effect can be experienced. Okay, magnetic effect can be experienced here. Is it clear? Okay, so you can say that the space around the magnets. A space around the magnet means, suppose that you have the magnets, and now you can see that you brought the, okay, another conductor. Suppose that I have the pins, and now you brought. You will see that at a certain points it started to attract. So this space from where it is attracting, so that is called their space. A space means what? From where it can attract the conductors, the irons, okay, and such type of attractions on that certain area, certain space. You can say that this is the field of the magnet. Is it clear? And same things also you can say that electric fields, from where the electrics can be, okay, observes around the conductor, and just like we have the, okay, magnets, and you know that here the charge is percent. Okay, so any types of conductors you can browse here, you will notice that here will be, okay, some force will experience by this charging body. Is it clear? Okay, very good. Now you know that if you will discuss about the, okay, conductors, now can, okay, silent erase these ones. If you have retains, or you can take captures also, students, because together you will make the notes, that would be better. Okay, so silent erase. Okay, very good. Now today we are going to discuss the very important questions, that is called the Biot-Savart law. What is the Biot-Savart law? Okay, Biot-Savart law, and another you can say BSL. Okay, BSL, Biot-Savart law. Biot and Savart are, okay, two scientists, okay, and they developed, this is, you know, this is the basic, what we can say that properties. This is the basic things where it can use to find the electric or magnetic field. Is it clear? Okay, very good. So Biot-Savart law, you will notice that suppose that we have a conductor. We have a conductors. You can assume this is the X and that is the Y, and take suppose that the current I is flowing through this conductor X to Y. Now you assume that here is the a points O and here this is the space around. This is the space around. Just like you know that, suppose that whenever the current will flow through these conductors, and you know that due to flow of currents in the conductors, in the coils, it behave like as a magnet. So assume that this is the magnets, and at a certain distance it will started to attract. So assume that we have this distance. This is the points where the magnetic field can be observed. So as suppose that V is the magnetic field, V is the magnetic fields, and R is the distance between them. R is the distance between them, and suppose that theta is angle between them. When these lines where the observation points, and this elementary you can take here, this is the elementary, you can dark here, this is the A and B, and this is the length DL. Length DL, if you will assume total length is L, so this is the elementary portion, that is the DL, and R is the distance from where the magnetic field can be observed. Is it clear? Okay, so according to Biot-Savart law, okay, Biot-Savart law experience that when the continuous current flows in these conductors, the magnetic fields can be observed. Yes, according to Biot-Savart law, according to Biot-Savart law, when current is flowing through the conductor current flowing through the conductors, the magnetic field can be experienced, and it is depends on flowing factors. Okay, flowing factors, just like you know that it is directly proportional to the current flowing. That means it is directly proportional to the current flowing. Yes, current flowing. That is, you can write here dB is directly proportional line. Can we write here? Okay, very good. So first equation we got. Also we know that it is directly proportional to the elementary portion. That means you can write here dB directly proportional dl. This will be question second. Can we write here? Okay, very good. Another you can third also you can write. You know that it will depends on this portion, the elementary, the currents, and the angle between them. Yes, it is directly proportional to the sine of angle between the current flowing and the line joining the elementary portions. Okay, very good. That means dB directly proportional sine theta. Okay, very good. So this will be equation third. Okay, we got three equations, and you know that here is the distance, so it is also, okay, it is also, or it is inversely proportional to the square of distance between them. That means you can write dB directly proportional, R Inversely, yes, 1 by r square. Now you have 4 equations. How many equations are there? 4 equations. What? First is that when the current flows through x to y, so the magnetic field will generate. So magnetic field, that means you can take the dB is directly proportional to current, dB is directly proportional to this elementary portions A to B here, okay, and dB is directly proportional to this sine of angle of theta, and another's the inversely proportional to the square of distance between them. Okay, so now you can combine this all equation. Okay, now combining equations 1, 2, 3 and 4. If you will combine here, then you will write, all having the same dB and all. So you can write here dB directly proportional. What you will write here? I dl sine theta. I dl sine theta by r square. Can we write here? And as you know that whenever you will remove this, okay, proportionality, it is this, okay, very good. So, or you can write here dB equal to Ki dl sine theta. Ki dl sine theta by r square. This is the formula that you can use to solve the numericals. Okay, students. And another, that in SI units, K equal to mu naught by 4 pi. Yes, K is equal to mu naught by 4 pi. And this value you can also put, the value of mu naught by 4 pi is equal to 10 to the power minus 7 Tesla meter per amperes. Tesla meter per amperes. So this value you can put. Therefore, dB is equal to mu naught by 4 pi and I dl sine theta by r square. Can we write here? Okay, and also you can put their value. So you will use this one whenever you will solve the numericals related to the magnetic fields. Is it clear? So that's the very important questions. And also you can write this is the value whenever you will find the magnitude value. Also you can write or dB, d factor dB is equal to mu naught by 4 pi into I dl. Yes, what you will write? I dl means, and you will take the vector signs, and that gives, whenever you will take this elementary portion here, this is the unit vectors which represents the directions, directions you can represent here. This is the A and this is the B, this is the dl. Okay, and here is theta. So this is the, okay, magnetic fields, and this is the unit vector which points the particular directions. So you can write here I dl cap of r and by r square. This will be the final value. Is it clear? Or you can write, you can multiply and divide what? R. Also you can write here, or you can write dB equal to mu naught by 4 pi I dl, and that if you will remove this cap off, so you can multiply r by, okay, and also you have to divide. So here will be dl cross vector r divided by r cube. Can we write also this formula? Okay, very good. So this is the questions that you can find. Also you can find the totals. This value you got for these ones, and if you want to find the total, then you can put, what you will put, you can also find the total magnetic field, total magnetic fields. Okay, total magnetic fields. Okay, students, we can find out. Okay, and those who are the new students, please subscribe my channels. Okay, share this video if you have understands, and if you have any problems, you can comment. Okay, I will wait for your comments. Okay, very good. So now come to the point, and now put this value. So you can write here b is equal to integration of dB. Can we write here? And this value you can put here. So b is equal to integration of, either you can put this value, integral this value also and this value also, as you like. Okay, or you can put dB, that means what? Mu naught by 4 pi into I dl cap of r by r square. This you can find. So this will be the value. Okay, Okay, student, thank you. And next class also I will try to come regulars. Now, as you know that the channel has been monetized. Now we can, okay, efforts more. And if you will share, if you will see the video, continue without skipping. Okay, I will put my best efforts to give the best class. Okay, and also subscribe my channels, those who have not subscribed, and those who have subscribed, thank you for, okay, okay student.